So in this video, we will see about linked list. So in the last video, we saw about what is list, how to create a list using array, and what are the advantages of array, and what are the limitations of array, and how to create a list using dynamic memory allocation. So, for example, if you want to store a mark of 5 subject, then in array we need to create an array of size 5, and then after creating array you can able to store that 5 marks in that same array, and you can able to directly access any value by using the array index. So in that video we also discuss about how actually that memory address of each element can be calculated using the starting address of the array. So next, so the main limitation of array implementation is so the array is a contiguous memory location. So we can create a array if there is enough contiguous memory block is available. So by using dynamic memory allocation, we can able to create a list in which each element in the list can be stored in a non-contiguous memory block. So for each element, we are creating a memory block, and then we can use that memory block for storing the value. So in C, we know how to create a how to use the dynamic memory allocation by using malloc and calloc functions. We can able to create a dynamic memory. So if you want to store, if you want to create a list that contains 5 integer element, okay. So in a simple way, we can create 5 dynamic allocated memory block of size integer. So for example, if you create 5 blocks like this, so each block have its own address. For example, the first block address is 2000. So second block 3000, 4000, 5000, 600, 6000 respectively. Now, so here all the elements belongs to the same list. So we can able to traverse from one element to another element. That means these elements should be arranged in some order. So if you use array, that index, by using the index, we can order the elements. So index 0, first element, index 1, second element. But here, how to order this? Suppose if you want to access the fourth element of this list, if it is a array, then that index 3, fourth element index 3, so that mark 3 will return you the fourth element of that list. But here we create memory location, a non-contiguous memory location. So if you know the address of the first element, that is 2000, from that address, now we cannot able to find what is the address, or in which address that fourth element is actually stored, because we don't create any link here. So that memory blocks are not linked. So this is a random list. There is no link between the element. From one element, from the start element, we cannot able to reach any other elements. Okay. So how it can be done? By using a simple method, a simple way, that is called linked list. That means here we are going to create a link between consecutive elements. Okay, that means from the first element we can able to reach, or we can able to retrieve the address of the second element from the second element. That means from the memory block that is allocated for the second element, we can able to retrieve the address of the third element. In general, from the memory block of the ith element, we can able to retrieve the address of the I plus 1 element. Okay, there is a simple linked list. So how to retrieve it? So in a simple array, each index, so we are going to just store the actual data, but in a linked list. So each element should have the address of the next element apart from the actual data that we are going to store in that particular um, index. So we particular node here, this is called node. So in array, that is called index. Here each element is represented as a node. So in each node, apart from data, actual data, we need to store the address of the next element also. We suppose this is the address of the next element 3000, and in this first node, so actual data 100. For example, if the data actual data is 100, apart from the data, we need to store the address of the next element. That means 3000 should be stored here. In the same way, in the second node, apart from the actual data, the address of the third node should be stored. So now we create, by using dynamic memory allocation, we create a memory block in a non-contiguous memory locations, and we also create a link between the data. Here it is called node. The node link between the node is nothing but the address. Each node contains the address of the next node. Okay, so this is about the introduction about the linked list, actual concept, basic concept of the linked list. In the next class, how this linked list means nodes can be created. We will discuss that in the next class.